Hello learners, my name is Dr. Nidhi Singh. I am Assistant Professor in Geography and today we will be learning about dynamic surface of the earth. So, what is the aim of this session? So, in this session we will be learning about endogenetic forces, effects on transforming landforms, isostasy, views on isostasy and then plate tectonics and continental drift theories. Isostasy. What is isostasy? It is derived from the word isosteos. It is derived from the word isostasios. It's a Greek word and it means state of being in balance. So, there is great difference in height on the earth's surface. Mountains are very high while plateaus are lower and then plains are very low. So, earth is rotating and keeping perfect balance among all these features of different height. In this manner, earth is in isostatic equilibrium. So, isostasy can be explained with two viewpoints as you can see in the picture. One is Airy's view of isostasy, which says there is same density but there is varying depth of various features on the earth's surface. By Pratt's view, which says there is different density but there is same depth. Now, first of all we will be dealing with Airy's view on isostasy. Airy was a geologist and he said that density of different columns on the earth's surface is the same. So, different columns, what do we mean by that? That is plains, plateaus and mountains, etc. So, according to Airy, the density of all these features are the same. So, there is uniform density, so there is uniform density with varying thickness. So, according to Airy, Earth's crust is made up of lighter material of silica and aluminium, which is known as Cr. We have already discussed in previous sessions. Then the lesser dense layer is floating on the denser material, that is CIMA. So, it assumed that Sialic crust is floating over CIMA. The crustal layer or the Sialic layer has uniform density. This was assumed by Airy, but there is varying depth of column length. The columns are projecting down into asthenosphere depending upon the proportion of the columns. So, Airy's view you can clearly see in the diagram. He used wooden blocks to explain his viewpoint. Here wooden pieces of uniform density was taken and this was dipped in water. So, according to Airy, all the blocks had same density. So, they got immersed differently in proportion to their sizes. So, longer columns were immersed more into the water while the shorter columns had lesser depth in the water, as you can see in the figure. Now, Airy's view, if we take into consideration the earth's surface, you can see in the picture three types of columns or features is shown: mountains, plains and plateaus when immersed in water or when it is immersed inside the earth in asthenosphere. So, mountains, they go deeper than as compared to plateaus and then as compared to plains. Now, according to Airy's viewpoint then, so the root beneath Mount Earth would be approximately 70,784 meters below sea level. So, on this ground Airy was criticized because if this at this depth, if Mount Everest is floating or it is rooted beneath the earth's surface, it will melt because it is very hot inside the earth's surface. So, on this ground Airy was criticized. On the other hand, Pratt was another geologist who explained isostasy, and according to Pratt, he considered land blocks of varying heights with different density. Airy had explained same density. Pratt explained about different density of various columns. So, taller land masses will have lower density while shorter land masses will have denser or will have greater density. So, there will be an inverse relationship between height and density. Pratt's view can be explained in this manner as you can see in the figure. So, there are two columns, one with lesser density, that is high with longer length, and then more denser will have a shorter length. So, when immersed, Pratt used mercury for immersing, and then when immersed in mercury, both the columns with varying density floated at the same level at along the line of compensation. So, a line is being demarcated above which equal pressure with varying heights can be seen. Pratt took metal bars of varying density with same weight and put it in mercury. They formed a line with all bars and a level of compensation, and at a level of compensation all the bars were floating. So, the difference of views between Airy and Pratt can be explained in the figure. First one is for Airy's view and second one is for Pratt's view, where a level of compensation is being seen. Now, the difference can be also written, can be seen in the plate. 1, 2, 3, there are differences between Airy and Pratt's view. Uniform density for Airy, then for Pratt's view there is varying density, then likewise. Now, global isostatic balance, we will be discussing about that. If we see, there is no complete isostatic balance on the earth's surface. Earth is very unstable and the endogenetic forces that take place within the earth's surface often disturb the crustal balance. Evidences can be seen in the form of regular earthquakes that take place and then volcanic eruptions that are taking place on the earth's surface. Therefore, they signify there is no complete balance on the earth's surface and there is need for adjustment, but nature always tries to make an isostatic adjustment on its own. So, exogenetic forces also eliminate differences on the earth's surface through weathering, transportation and deposition, and in this process isostatic balance is maintained. Endogenetic as well as exogenetic forces, both of them maintain isostatic balance. How this is done? For exogenetic and endogenetic forces together, for example, underneath flowage of material, that means underneath the earth's surface there is flowage or movement of material. Second one is subsidence at place of deposition. Then third is upliftment at place of erosion, the proportion to denudation. So, these are the three ways in which global isostatic balance is maintained. Now, the mechanism of isostatic adjustment can be seen in the picture. There is transportation, deposition, erosion and then a flowage of material inside the earth's surface in the SEMA you can see. Now, we learnt about endogenetic forces and how they transform earth's surface, then endogenetic forces, exogenetic forces, isostasy, Airy's and Pratt's viewpoint. Now, little bit related to this, all these isostasy and balance and everything, we'll be discussing about continental drift. This was the theory that was propounded by Alfred Wegener. According to this theory, entire landmass of globe was together around 280 million years ago and gradually it drifted apart, it broke down and drifted apart horizontally. There was a Pangaea around 280 million years ago and that was a supercontinent, and this supercontinent was, as I said, it was known as Pangaea, and there was a huge water body surrounding the Pangaea. There was a landmass called Pangaea and huge water body surrounding the Pangaea, and that was known as Panthalassa. As you can see in the picture, Pangaea is there, all the land masses are combined together to form a continent, and that is Pangaea, and the whole water body surrounding it was called Panthalassa. The colored picture you can also see in this, Pangaea and Panthalassa. Now, gradually during 280 to 150 million years ago, what happens, Pangaea broke down latitudinally, that means horizontally, and moved apart. The northern part was known as Laurasia or Angara land, while the southern part was known as Gondwana land, and in between, when they drifted apart, in between a shallow sea was created between the northern part and the southern part, and that was known as Tethys Sea. Water from Panthalassa seeped in, and then this shallow sea was formed in between the northern and the southern landmass, or the Laurasia or Angara land and the Gondwana land, and this was known as Tethys Sea. As you can see in the picture also, they are moving apart and gradually Tethys was formed. Now later what happened, Laurasia and Gondwana land further rifted apart and finally drifted to form present day distribution of land and water on the earth's surface. As you can see, further there is rifting and drifting of the land masses. In the picture you can see that. Now what are the evidences of this continental drift? So whole this drifting is known of continent of the land masses is known as continental drift. And what are the evidences for this drift? We will be dealing with that. First one was Wegener gave number of evidences in support of unification of land masses and geological past, which cannot be even negated today. We cannot say that this did not happen. So there are several evidences. First one is jigsaw fit. In that, eastern coast of South America can be seen identical to western coast of Africa, which fits to certain depth in the ocean. So to an extent, coastal areas and continental shelves are little modified and through by oceanic waves or through denudation, but they can be fit in, they can be jigsaw fit. As you can see in the figure, both the parts of Africa and South America can be fit in. Second one is geological similarities of land masses. So mountain system of southern Atlantic Ocean of South America and Africa can be found similar. There are extension of in both the continents. Third one is coal and vegetation evidences. Distribution of coal and vegetation of South America, Africa, India and Australia can be found little similar. It proves that they were together in the past. So classical glacial deposits like a Carboniferous period over these land masses resemble each other. So today they lie in different climatic zones. You can see the vegetative and animal remains that were found similar in these continents. Fossil remains can be found similar in these continents. So it shows that maybe they were together in the past. Now another evidence is, the fourth is the evidences from paleomagnetism. What is paleomagnetism? It is the study of direction of pole through ages. So direction or movement of poles through ages. What happens that magnetically susceptible minerals like hematite, pyrrhotite and magnetite etc. get aligned with magnetic pole of the earth. The recorded solidification of magma during that time can be seen. Periodic changes have occurred during in this solidification of magma and then formation of poles. So poles have wandered, which is not possible for entire earth but a land block. So it also shows that some land blocks have shifted from their original places. Another evidence is sea floor spreading. So along the mid-Atlantic ridge, magma comes out of the sea bed. We studied, we learned earlier also in the earlier session that magma comes out along the mid-Atlantic ridge and it gets solidified. So new zones, whenever there is magma coming out, new zones are formed and new sea floors are found along this zone. This process continuing since millions of years ago, and there is diversion of continental block and increase in size of Atlantic Ocean. This is known as sea floor spreading. So the sea floor is spreading gradually in the Atlantic Ocean near the mid-Atlantic ridge. So there is example of shifting of continents also. So explanation of continental drift through sea floor spreading and study of paleomagnetism has supported, and this is known as, basically this is known as plate tectonics. Example of sea floor spreading and how it happens can be seen in the figure. So what happens that magma comes out and gradually in the first, the lowermost figure you can see the magma is coming out, gradually the sea floor is spreading, and then in the third picture you can see the still magma is coming out and several layers, new layers are formed along this layer. Now we will be learning about plate tectonics. So there is solid mantle and upper crust, and these form lithosphere or the rigid block on the earth's surface. So magma is partially molten and then upper solid block is floating above it. This molten magma zone is known as asthenosphere, which is 100 to 250 kilometers in depth. It is also known as Moho discontinuity, and it is named after a seismologist called Mohorovicic. So, what plate tectonics explains that the lithosphere is broken into several blocks, or that is known as plates. So, these plates move over the asthenosphere. There are 7 major plates, the names you can see here, and in the picture you can see the 7 major blocks or plates and few smaller plates also, and there are 20 minor plates. Few of the examples are given here. Now, these major and minor plates encompass the whole surface of the earth, and this method of way of understanding the land and water distribution on the earth's surface is known as plate tectonics. Tectonics means movement of plates. So, what happens that movement happens due to internal forces, and then this is responsible for distribution of earth's surface, and then formation of mountain chains and distribution of earthquakes and volcanoes on the earth's surface. What is the mechanism behind plate movement? So, we learnt about plate tectonics. So, how this movement of plates takes place? Arthur Holmes, who was a British geologist, explained this movement of plates through convectional currents that exist underneath the lithosphere. This is the center of convectional current is not exactly known, but it is believed that an average depth of 100 to 250 kilometers this emerged below the earth's surface. So, what happens that radioactive minerals that are found inside the earth's surface, they disintegrate, and then atomic minerals are formed, and the heat is produced during disintegration, and this results in melting of surrounding rocks, and then inception of or starting of current takes place. So, there are 2 types of currents, that is rising current and then falling current. Rising current is also related with divergent activities, and falling current is related with convergence activities. So, in the figure you can see rising current and then a falling current. Now, rising convection current results in transportation of hot and viscous material upwardly until about 100 kilometers below the surface. Then this current gets diverged, split into it rises and gets split into 2, and then it gradually descends, and where there is a splitting, new surface magma comes out and new surface on the earth's surface is formed. Subduction of mammoth plate in opposite direction takes place when there is submergence, and then it happens below the mid-oceanic ridge. Other side, when there is rising of current, the other side, here when there is rising, the plates move apart. For if we consider this as 2 plates, so when there is rising of magma, here the plates move apart, and on the other side, if we consider this other side, so here there is, when the currents move down, so where there is coming together of the plates, and then subduction happens. Suppose this is a lighter density plate, so it glides over the heavier density plate. So, there is subduction takes place. So, on one side where there is rising of magma, diversion of plates takes place, while there is coming down of magma, subduction takes place. There are plate boundaries also, there are different types of plate boundaries which we will be dealing with, and along this subduction or divergence takes place. Plates are continuously moving, and they have relative direction and movement. So, based on direction of movement, there are 3 types of plate boundaries. One is divergent, second is convergent boundary, and third one is fracture or transform boundary faults. First one is divergent plate boundary. So, where there is rising of magma, divergence of plates takes place. So, this is the place of construction also, because magma comes out and then it gets solidifies and new features, new surface is found. So, this is, for example, if these are 2 plates, so when they are moving apart from each other. So, this is called, this boundary is known as divergent plate boundary. The picture also you can see divergent plate boundary. Then there is second boundary, that is convergent plate boundary. Here what happens that magma subsides there, and then the plate bound, the two plates come together, and this is convergent plate boundary. Here what happens, if there is a varying density, suppose oceanic plate is little greater in density and the continental plate is little lighter in density. So, suppose for example, this is continental, this is oceanic plate, and this is heavier or more dense, and this is lesser dense. So, what happens, the denser plate subsides down under the lighter plate, that is continental plate. Okay. So, this in this manner convergent plate boundary can be seen. So, one goes down and one glides over it. Then in the picture you can see different types of convergent plate boundary, oceanic, continental, and then similarly. Then there are transformed plate boundaries where the plates slide past each other, parallel to each other. So, there is no subduction, no going down or anything, they slide past each other in this manner. So, it is known as zone of preservation. In the figure you can see that. So, plates are not permanent feature, they vary in shape and size, and they split and they join together. Tectonic activities, according to them, they come and go, drift apart from each other. So, continental drift theory was criticized, but then there is no other alternative to this theory, and therefore, but later what happened, that material of sea floor and paleomagnetism, all these things supported the theory of continental drift. Plate tectonics also supported that, and then it was proved that yes, continental drift took place millions of years ago and it is still taking place. So, plate tectonics is also related to earthquake and volcanoes, etc. So, there are several plate boundaries where volcanoes and earthquakes takes place. You can see in the map here the ring of fire, the red ring that you can see along this is the where there is earthquake and volcanoes take place. The hotspots are also known for this, and this is also ring of fire where there is a distribution of earthquakes and volcanoes has taken place. These are common places where lots of activities, tectonic activities take place. So, in this session we learnt about endogenetic forces, isostasy, global isostatic balance, tectonic plates, plate tectonics, and then evidences of plate movement, continental drift theory, and then occurrence of or distribution of volcanoes and earthquakes on the earth's surface. Thank you.
प्रकाशित करने राहों को आलोकित करने हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने। जीवन ये प्रकाशित करने राहों को आलोकित करने।
धन साधन समय की सीमा से विद्यालय जो मुक्त हो, धन साधन समय की सीमा से
कभी पढ़े हम कहीं पढ़े वे विषय की लोच से युक्त हो,
कभी पढ़े हम कहीं पढ़े वे विषय की लोच
जीवन ये प्रकाशित करने, राहों को आलोकित करने।
शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर।
शिक्षा और परीक्षा का अवसर एक बार ही क्यों मिलता फिर। दुनिया में इसके केंद्र बहुत, कोई मन चाहा केंद्र चुने, हम अपना जीवन स्वयं बने, हम अपना रास्ता स्वयं चुने। कोई मन चाहा केंद्र चुने, स्वयं बने, हम
घर बैठे पाएं राष्ट्रीय मुक्त विद्यालय शिक्षा संस्थान यानी NIOS में एडमिशन, वो भी एकदम आसान तरीके से, जिससे शिक्षार्थियों को होगी समय और धन दोनों की बचत। NIOS से शिक्षा कभी भी कहीं भी। शिक्षार्थियों, क्या आप जानते हैं NIOS में एडमिशन लेने का सरल और सुगम तरीका, जिससे शिक्षार्थियों को ऑनलाइन प्रवेश लेने में सहूलियत मिलती है। NIOS में प्रवेश की प्रक्रिया पूर्णतया ऑनलाइन है। शिक्षार्थी घर बैठे इंटरनेट द्वारा प्रवेश के लिए सबसे पहले NIOS की वेबसाइट www.nios.ac.in पर लॉगिन करें। अपना ईमेल आईडी और पासवर्ड डालकर अपना पंजीकरण करें। पंजीकरण के बाद लॉगिन करने पर ऑनलाइन प्रवेश हेतु आवेदन पत्र खुलेगा। आवेदन पत्र को निर्देशानुसार भरें और प्रिंट आउट लें। इस प्रिंट आउट पर अपनी फोटो संलग्न करें। ऑनलाइन प्रवेश के लिए शुल्क हेतु भुगतान के तरीके हैं: क्रेडिट कार्ड के द्वारा, डेबिट कार्ड के द्वारा, राष्ट्रीयकृत बैंक के ड्राफ्ट के माध्यम से, जो कि सचिव NIOS नई दिल्ली या नोएडा के पक्ष में देय हो। भरे हुए आवेदन पत्र के साथ साथ डिमांड ड्राफ्ट और संलग्न किए जाने वाले दस्तावेज हैं: जन्म रजिस्ट्रार के जिला कार्यालय से जारी जन्म प्रमाण पत्र की सत्यापित प्रति, जिसमें जन्म तिथि अंकित हो, पिछले विद्यालय से प्राप्त विद्यालय छोड़ने का प्रमाण पत्र, जिसमें आवेदक की जन्म तिथि लिखी हो। प्रवेश फॉर्म का प्रिंट आउट NIOS के संबद्ध क्षेत्रीय केंद्रों पर 10 दिनों में पहुंच जाना चाहिए, अन्यथा उचित दस्तावेज न लगे होने पर आवेदन फॉर्म रद्द किया जा सकता है। प्रवेश प्रक्रिया की पुष्टि होने के बाद शिक्षार्थियों को परिचय पत्र व अध्ययन सामग्री डाक द्वारा तुरंत पहुंचाई जाती है। ऑनलाइन प्रवेश एक बहुत ही सुगम और सुविधाजनक प्रवेश प्रणाली है। ऑनलाइन ऑन टाइम फॉर सेफ एंड सिक्योर एडमिशन।